Two functions are represented in the tables below. Generate an equation and a graph to represent q of x and p of x. Use all three representations of q of x and p of x to generate r of x equals p of x times q of x. Compare the three representations. Okay, so we have our tables here. Let's first find the equations. So looking at these, a common way we often do it is by finding the finite differences, but immediately I actually saw a different pattern here. I just see that there's a 3 in every single of the q of x values, and then I noticed that, the first one has two decimal points or two decimal places. The second is just 1, and then none, and then 2, and then 3. And so that just tells me the decimal place each time is just being moved to the left 1, which is just the same thing as being multiplied by 10. So I can tell 30 divided by 3, we know that's just dividing by 10. So, I'm multiplying by, basically I'm multiplying by 10 each time here. And so, because 30 times 300 is 10, and same 300ths times 10 is 3/10. Um, so this is going to be an exponential relationship. And remember that our exponential relationships are y equals a times b to the x, and a is just the y-intercept. And so here we see that the y-intercept is 0, 3, and so that's going to be our a value. So we can write q of x equals a, which is 3, and then b is the factor it's being multiplied by each time. Or in other words, it's the bigger y value, or the second y value, I should say the y value with the bigger x value divided by the y value of the smaller x value. So it's just 10 in each of these cases to the x. Let's go ahead and find for p of x. So looks like a similar relationship here. Again, you see that the decimal place just being moved to the left 1 each time. And also if you divide, 50 divided by 5, that's 10. 5 divided by a half is 10, and so on. So again, it just multiplies, it essentially multiplies by 10 every single time, or divides by 10 if you're going down, basically, as the x values get smaller. And so our value here will be p of x equals the y-intercept. So in this case, 0, 1/2 will be the y-intercept. So that'll be 1/2, and then times 10 to the x. And so here we have our two equations. So then to multiply those two together, then we can just do, well, q of x times p of x will equal 3 times 10 to the x times 1/2 times 10 to the x. And so multiplying those together, 3 times 1/2 is just 1/2. And then 10 to the x times 10 to the x will be 10, and then x plus x is 2x. So that will equal r of x. So there is our r of x equation. Okay, so let's go ahead and also find the r of x values in a table. The way that I do this in my head is I just do 3 times 5 is 15, and then I just count out the number of decimal places, and that will be the number of spaces it is behind the decimal point. So there's 2 places there, and then so 1, 2, and then 3 places here. So that's 5 decimal places, and then 3 times 5 is 15. So I'm just going to go 5 behind, 1, 2, 3, and then I still have the 15. So that's what it multiplies to. You can also just use a calculator or multiply it out in another method, but that's the way that I'm able to do this mentally. So on the next one, doing that same method, then we get 15 thousandths. 3 times a half is 1/2. 30 times 5 is 150. And 300 times 50 is 15,000. So while we're looking at r of x, then let's actually look at these table values and compare it to this equation here and just plug in a couple values to see. So if we plug in 1 into r of x in our equation, that's 10 to the 2 times 1, that's just 2. So 10 squared is 100 times 1/2. That's going to give us 150. So we see that it does match when we plug in 1, and if we plug in 0, 10 to the 2 times 0, that's just 0. 10 to the 0 is just 1 times 1/2. Well, that's 1/2. So these do match up so far. Now let's go ahead and graph these values. For simplicity, I've just put our values in the table here. And so graphing, okay, so first let's just do p of x. So we have -2 and 3/100ths. So that's just right above y equals 0, -1, 3/10. Again, that's just about a third above 0. And then 0, 3, and so on. Okay, so that's a pretty terrible line there, but we get the idea that it's going to be an exponential and it's going straight up. I'll have a nicer version for you to look at in just a minute here. And then for q of x, let's go ahead and plot those. So for q of x, then we have -2, and again, it's just right above y equals 0, -1, right above y equals 0 again at 5/100ths, and then 0, 1/2, 1, 5. This one's a little bit easier to graph, and then 2, 50. So that goes way up off our graph, so we just know that's going to start really small and then explode upward. For the last one, then let's go ahead and graph r of x. So similarly, -2 is really, really small above 0. Again, really small above 0 for -1, and then at 0, 1/2. At 1, 150. So that just shoots right up there, and at 2, 15,000. So it's going to go really high, really, really fast. Okay, and so let's go ahead and I'll just show you a nicer version of these. Okay, so here is just the same thing, but here with the different values in and a nicer lines there. The red line is going the steepest there, and if we multiply, all of the y values in this equation, the y value of the green line, q of x times the blue line, p of x, those do equal the y values of the red line, which is r of x. And so we see that does follow, and then also looking through that p of x equals 3 times 10 to the x. Q of x was 1/2 times 10 to the x, and then r of x was 1/2 times 10 to the x. And we see that in our equations on the graph, then p of x does have an x-intercept at 3, q of x does have one at 1/2, and then r of x does have one at 1/2. And then also we see that, r of x was 1/2 times 10 to the 2x. So we also see that r of x progresses faster because of this 2x exponent instead of just the x exponent. And so we see that that does, line up with our equations. So let's summarize our answers. So our answers are the graph, the table, and then the values in the table can be used to determine that both p of x and q of x are exponential functions with a base of 10. Therefore, p of x equals 1/2 times 10 to the x, and q of x equals 3 times 10 to the x. Since r of x equals p of x times q of x, using multiplication and laws of exponents, r of x equals 1/2 times 10 to the 2x.